So today our group will be presenting case study number 2, which is about the Diarizhos River in Cyprus. So this case study focuses on the Upper Kramos Dam, which is located in the southwest region of Cyprus. The dam consists of a population of 3,550 people, and it provides water supply to the communities in the basin area. There is water use competition and also water shortage due to climatic conditions and also political reasons. The southwest of Cyprus is quite dry in summer and also in autumn. So they have proposed the construction of recharge dam at the Diarizhos River near the Upper Kramos Reservoir and also Mamunia to cater this problem. The aim of the recharge dam is to increase the water reserve of underground aquifer and also to utilize the surface water that would otherwise be lost. And also it works by retaining the water flowing on the surface behind a structure and then forcing the water downwards into the underground system. So this is a map showing where the proposed recharge dam will be constructed.
Before we talk about the social impacts, we first have to remember that we don't know anything about the water supply to the area, so we're going to assume that the Upper Kramos Dam can supply water to the entire region. The first settlement which might be affecting the region will be the village of Nikokila, which has a large kind of olive industry, so that will obviously benefit, but the town also has a rising tourism area through agritourism, and that could be badly impacted if the nature of the area is impacted by the reservoir. The impacts are potentially more positive to the south in Kukula, where some of the tourist destinations will be affected by the loss of nature, but most of them are located to the right side of the town to a different river, and therefore they'll be more successful. And the south area has a lot more agriculture on the west side where the river is, so overall there'll be far more benefits. Well, the social impacts are mostly positive. It's worth remembering that there is a town or village called Sotki, which is abandoned but has an important archaeological site. So for the region, it may be worth kind of doing some tests in the area before potentially doing any reservoir building in that area.
So for the next part would be the risks, and it will be divided into environmental and social risk. For the environmental risk, building of the recharge dams may involve removal of vegetations, and therefore this will lead to habitat loss as well as biodiversity loss. In addition, since water will be retained in the recharge dam before it is infiltrated, huge amount of water loss may occur through evaporation, and this will affect the microclimate of the area as it causes fluctuations in extreme temperatures. This will subsequently affect any living organisms surrounding the dam. And as for the social impacts, will be entirely on health risk. Water in recharge dams is primarily rainfall runoff drained from different land use of the catchment. Hence, recharge of this water may change the hydrochemical characteristics of the resident groundwater, and this may lead to contamination. This will then affect the health of people if the contaminated groundwater is supplied for drinking. The next part is the life cycle of the recharge dam, and this will discuss on the impacts of each stage of project design. The first stage of the project design will be site selection, and geologically suitable sites that are selected may be highly populated sites and hence may result in local resentments due to relocation. It may also be an agricultural area or area with unique biodiversity, such as one of the Natura 2000 network sites. The second stage would be the construction and operation of dam impacts. The water retained by the dam may cause inundation of vegetation, which not only result in habitat loss, but it may also take a long time for all this organic matter to decompose. And when they do, they release greenhouse gases such as carbon dioxide and methane, which contributes to global warming. And the last stage of the project design would be the completion of dam. Upon completion of dam, it may require high maintenance for periodical removal of clogging layers, which may be labor intensive and hence might cost the country more. However, it may also not be functional during dry periods, as no water will be retained nor infiltrate into the groundwater, and over a long term it may result in loss of jobs. Lack of maintenance nor awareness of the surrounding construction work may result in the dams being obstructed by roads and be filled with sediments, such as what happened to the recharge dams in the southeastern part of Cyprus.
The condition under the reservoir is anaerobic, meaning that vegetation under the reservoir are deposited by anaerobic bacteria that give enough greenhouse gases like methane and carbon dioxide. According to the whale and dolphin conservation, if the area being floated during the reservoir filling is not cleared out, the amount of greenhouse gases produced could be higher than energy produced by a coal power station. Researchers found that vegetation in the water means that the dams about 1 billion tons of greenhouse gases every year. This represents 1.3% of total annual anthropogenic global emission. When considered over a 100-year time scale, dams produce more methane than rice plantation and biomass burning.
We recommend that we continue the proposed project, but with full environmental impact assessment, as there are plenty of risks and societal impact. We also recommend that there's more information on the geology details and also the cultural heritage of the site, because just in case we do not build the dam on any location that has some cultural value. And the next one is that we recommend some more information or dimension of the recharge dam, so that we can see how the magnitude of the impact the construction of the dam will give to the environment itself. That's all from us. Thank you.